picking up good vibrations.
We start by illustrating convolution for signals that have a bounded support. That means that they are 0 outside a bounded interval, and they're also 0 for negative n. We know that in this case the formula simplifies to the summation from k equals 0 until n of x of k times h of n minus k. To help us understanding convolution, I will use my hands as to denote the two signals x and h. I'll use my left hand to denote x and my right hand to denote h. I'll assign numerical values. To my thumbs, I assign the value of 0.5. To my forefinger and my ring finger, I'll assign the values of 1.5. To my little finger, the value of 1. And to my middle fingers, I will assign the value 2. So in the formula, we see that x will remain static. So it's a summation from k equals 0 until n of x of k. That will not change. But h depends on n. And we start with n equals 0 in the formula. So we have to consider the product between x, which is static, and h of minus k. What is h of minus k? Is a reflection about the signal axis. We first reflected, we didn't have to multiply it when you consider the multiplication of x of k and h of minus k. We get a signal that is 0 everywhere except when k equals 0, in which case it is equal to 1 times 0.5. So it's just a signal that is 0.5 when k equals 0 and 0 everywhere. And when we add it in an interval from k equals 0 until n, we simply get 0.5. Then we continue the procedure by multiplying for n equals 1, in which case we have to multiply x of k, which always remains static, with h of 1 minus k. And that's basically a signal which is h of minus k shifted once to the right. Now if we multiply these two signals, we see that they are 0 everywhere except when k equals 0, in which case it is 1 times 1.5, so 1.5, and when k equals 1, in which case it's 1.5 times 0.5, so 0.75. So if now I add from k equals 0 until n these two values, I get 0.75 and 1.5, which amounts to 2.25. And that's the value of y1. We continue to compute y2, and for this we have to multiply xk, which always remains static, with h of minus k plus 2, or h of 2 minus k. So we see that in this case we get a signal which is 0 everywhere except at these three values, k equals 0, k equals 1, k equals 2. We have to multiply 1 by 2, 1.5 by 1.5, and 0.5 times 2. If we multiply this, we get a signal. If we add that signal, we get 5.25. And that's the value of y2. We continue this procedure. So we already did this procedure for n equals 0. We multiplied and we added. N equals 1, n equals 2. For n equals 3, we have to multiply x of k and h of 3 minus k. We multiply, we get a signal. We add it, and we get a value, which is y3. Then we get y4 by doing the same. We get y5, y6, y7, y8, and after n equals 8, so n equals 9 onwards, we get 0 all the time.